Hello everyone. Today I'll be looking at day one of Advent of Code 2021 in the Uiua programming language. And this problem asks us to take a list of numbers and count the number of times a depth measurement increases from the previous measurement. So for this test input, we expect to get 7. And we can do this very easily in Uiua. So we can take our input into the Uiua pad here, and we can turn it into a raw string. So we just have our string here on the stack. The stack grows downwards. And what we'll want to do is partition this string using the partition modifier. And you can see that this will group sequential sections of an array. So we want to group with a binary mask um, that keeps these sections and removes the new line characters. So we can do that by putting a new line character on top of the stack and then calling not equals to get that binary mask. And we want that raw string still, so we'll use the by modifier, call a function but keep its last argument after its outputs. And then we can use this to partition. And you can see that partition, like by, is yellow. So it's a monadic modifier, meaning it takes one function as an argument. And in the case of partition, it will call that function on the sections that are kept. So we want to apply parse to turn these strings of numbers into actual numbers. So we can give it the parse function, and you see here we now have our vector of numbers. And then what we want to do is compare each number to the next and check if it's greater. So in order to do that, we can use the stencil modifier, which will call a function on windows of an array. In this case, we want two wide windows. So something like this, right? We want to operate on these pairs. And we can do that by using stencil greater than. And the nice thing about stencil is that it can infer the size of the window based on the arity of the function that it gets. So greater than is a dyadic function, meaning it takes two arguments. So stencil knows to build two wise windows and then apply greater than between them. So with just this, we already have our list of times when there's a greater than occurrence, and we can simply add them up. And just to speak about this symbol, right? So this is reduce. So we basically want to sum all of these numbers, all of these ones. So apply a reducing function to an array. Again, yellow, so a monadic modifier. We give it add, and it applies the add function in between the rows of this array. In this case, the individual elements of the vector. So this is already our part one solution. Then part two asks us to effectively do the same thing as part one, but do this kind of pre-processing step where you consider sums of a three measurement sliding window first. So again, we're working with these kind of sliding windows. So rather than two elements, we want three wide windows. We want to sum these, and then we want to apply the same part one logic. So we could do something like this. So we're sort of explicitly indicating with this subscript that we want three wide windows, and then the function to apply is this same plus reduction sum operation that we just looked at. So this gets us what we would want. Alternatively, if we want to do the same thing that we did before, where we let stencil infer the size of the window, you can see here now that plus plus it forms an anonymous triadic function, meaning it takes three arguments. So it's really whatever you prefer here. I think I usually do this. And then we simply apply the same part 1 logic. So this already gets us our part 1 and part 2 solutions. And this is great. I think very succinct, very easy to understand, but we can consider the performance implications of stencil and whether or not in an array language there's a better way to approach this problem. So what if we were to do something like operate on the whole array at once? This is one of the main things that you try to do in array languages. So we can do something like shift the whole array over by 1. So you can see now that this whole original array has been shifted left 1 position, and I used fill 0 here to make sure that 199 didn't loop to the end, but was simply a shifted and a 0 in its place. So with that now, we can compare each of these elements at once using less than, and we can sum this, and you see we get the same answer as before. So yeah, I can also call this part 1. We'll have like a new part 1. And same thing for part 2. So rather than using these 3 wide stencils, what if we just took this same approach, but we did 2 rotations? So we can use the range function to generate a range with 3, so we get 0, 1, 2. And then we can say we want to rotate, or in fact shift, so we'll fill 0, rotate again, and we want to rotate this array 0 times, 1 time, and 2 times. And we can do that by using a sided rows modifier, which, oh, and this is the wrong side, you basically point it at the side that you want to repeat. So we want to map over these elements, 0, 1, 2, and keep this array the same. And then what we get here is the original array. So that was rotated 0 times, rotated once, and rotated twice. And now we can sum these columns, which is, again, a plus reduction. And then we have the same position we were at with our 3 wide stencil, and we can simply apply part 1 again. Yeah, and then we can assign this to part 2. So these are 2 ways of tackling this. I think this one is much more array-based and more performant, but it does cost a few more characters, so it depends what you're trying to do. And with 10 numbers, I don't know that the performance implications will really matter, but we could take a look at the full input. So if I just drag this in here, I can load the full input in, and now you see that we have, well, I think it's 2000. I can like check the length of this. Yeah, 2000 numbers. So we can, yeah, well, we can basically check the performance of this, so time it, and it looks like our original stencil solution is taking around 7 milliseconds, and, well, yeah, that's quite, I mean, it's like a significant, significantly faster, more than an order of magnitude faster to use this sort of rotation approach working with the whole array at once. So I hope that was interesting. Hope you learned something, and I'll see you in the next one. Thanks a lot for watching.